Hello my fellow YouTubers, back again with a new project. After a long time, I'm very glad to present you my new arc welder machine made from micro oven transformers. I'm sure that you have seen many videos in YouTube concerning this project, but here I'm going to give you some ideas in order to make a very efficiency welder machine and also adjustable welding machine. With this welding machine you can adjust the current that you use in order to weld thick or thin irons. So let's get started. Here we have, as you can see, the arc welder machine. You probably notice that the case is from an old inverter arc welder that I took the case and I repurposed it. Let's open the case and see what we have inside. First of all, you can see two big microwave transformer, that the only thing that is remain on the transformer is the primary winding here and here of the transformer. The primary winding. The primary winding is for 220 volts AC voltage, and of course I remove the upper winding that was first for the microwave and high voltage, of course, and I rewind it with a very thick and isolated wire, 4 millimeters in thickness, here and here. I managed to winding about 21 windings here and 22 windings at the other transformer, in order to have 20 volts, 20.5 volts AC voltage output and 22 AC volt from the other transformer. As you can probably understand, in order to have the nominal output from the for an arc welder about 40 to 45 volts AC, I had to connect these windings, this second sorry, I'm a little sick. The secondary windings here in series. Here is the output, here is the other input, connect in series with the other winding, and the other here output is this cable, and these cables are connected to the connectors, to the big connectors outside, to give us the voltage we need and the current we need in order to weld. Let's start from the easy part. Of course, as you can see, we have some temperatures here, and for that reason we need to have a cooling fan with this protective sheet here. This cooling fan is derived from this 12 volt DC power supply. It's a very simple power supply. This transformer, a fully rectified bridge, and one capacitor in order to take about 13 volts AC. Before we explain this part, this board here, I want to show you the front of the panel. All the arc welders have only some switch in order to change the windings and to have lower voltage and lower current for very thin metals. So here I adjust these connectors, fast connectors, to connect my cable. Also I have a main switch. I have a fuse, 20 amps fuse. I will explain the purpose of this fuse. And I have here the AC voltmeter in order to see and to adjust the voltage I want to in order to weld. And here we have the potentiometer that drives the little board inside and adjust the range of the voltage, the output voltage of the welding machine. So give me a second to grab a cable to connect and to see how all this is function. Okay guys, I'm back again. Here I have the main cable here, inserted from the back here. Let's connect the cable. And let's start the welding machine on. As you can see, bring the camera more closer here. As you can see, we have the full output voltage is about 45 volts. So with this potentiometer we can adjust the output voltage. You can hear the humming noise from the transformer up to 0 and increase again up to the maximum voltage. This is for adjusting the output voltage and the current we use in order to weld thin metals, as you can see. So we have an adjustable arc welding machine made from salvage parts. Okay, let's see now what is the little circuit that we left for explanation now. Here we have a dimmer. It's a simple dimmer that dims out lights. First of all, from the main power goes through to this main switch here, and we power on two things. The main switch power on this little circuit in order to power two cooling fans, one cooling fan here and the other cooling fan. It's a very microscopic cooling fan here. It's from LED headlights from cars. So first of all, we needed to have, of course, for the dimmer circuit, a large amber fuse, a large fuse. The original fuse here was 2.5 amperes. I increased it to 10 amperes, but the final value, it has to be 20 amps. So from this I have, and from the circuit I have the external fuse here, as you can see, 20 amps. But there is no the only thing. The transistor that the dimmer uses was BTA 6 amps only, the power. So I had to make an exchange to change this BTA 6 to a BTA 12 amps. So in order to stand all this current, the drawing current we need, I changed the previous heatsink here, nothing, piece of metal, with very good this transistor heatsink, and is cooling very well from the cooling fan at the back. But as you can see here, with a toroid here, the toroidal no transformer is like a transformer. I forget the word in English. I'm going to remember it. This coil, a toroidal coil that unfortunately get very hot when we dim the power at the lower voltages. Get very hot, so I managed to screw with the isolation between this metal, this aluminum sheet and the coil underneath it, in order to help it cooling very fast. And of course I add this little fan here, as you can see, turns on to cooling down the coil of the dimmer. So this is it, guys, but I have to warn you that this is extremely dangerous work to do. You have to be very skilled about the currents and also very skilled about transformers, electronics, because there is of course a danger of shocking and death. So I'm not going for details, because I refer to some people that know very well about electricity and electronics. This is, as you can see, it's a very cheap project. The transformer is for salvage microwave from the recycling bins, to the cable is, of course, again for a recycle bins. This is this power supply is from recycle bins. Here also the only thing that I had is this dimmer, and of course, as I mentioned before, I repurpose it in order to increase the amperage capacity of the circuit. So I'm going to show you how this welder works. I can tell you that it is amazing. For about $10 I manage. $10 costs only these connectors that I fixed to the old cables of the welding machine. Here the connectors, $10. The female and male connectors here at the welding machine. All the other was salvage parts. So guys, thank you for watching and enjoy the rest of the presentation by welding some samples. Thank you.